Theoretically, a main circuit box is generally preferred over a main lug for several reasons. 1. Safety. A main circuit box provides a safer connection point for the main electrical conductors. The conductors terminate into individual circuit breakers, which are then enclosed within a metal box. This design offers a higher level of protection for the conductors against physical damage, reducing the potential risk of electrical fires and accidental contact. 2. Convenience. A main circuit box simplifies the process of adding or removing electrical circuits in the future. To add a new circuit, you simply install a new circuit breaker into the box. Conversely, to remove an existing circuit, you just remove the corresponding circuit breaker. This modularity makes future modifications much easier compared to working with main lugs directly. 3. Flexibility. A main circuit box offers greater flexibility in terms of the size and type of electrical conductors that can be used. This is because the conductors terminate into circuit breakers rather than being directly connected to the main lugs. This arrangement permits the use of various conductor sizes, even smaller ones like number 10 or number 12 American wire gauge, which can be more easily routed through conduit. Now let's delve deeper into the technical aspects. When choosing between a main lug and a main circuit box, it's essential to consider the application and the electrical code requirements. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. For instance, NEC Table 310.15 B16, formerly NEC Table 310.16, specifies the allowable ampacities of insulated conductors rated up to 2000 volts 60 degrees Celsius through 90 degrees Celsius in free air, based on conductor size and insulation type. When installing a 100 amp service, the size of the conductors needs to be adequate to carry the load. As mentioned in the example, number 2 copper wire is used. According to NEC Table 310.15 B16, a number 2 copper conductor with a temperature rating of 75 degrees Celsius is typically rated for 95 amps. However, depending on the specific installation conditions and any applicable directing factors, a larger conductor size might be necessary to ensure it can safely carry 100 amps continuously. A number 6 ground wire is also specified. The grounding conductor size is determined by NEC Table 250.122, which relates the size of the circuit over current protective device to the minimum size of the equipment grounding conductor. For a 100 amp circuit, a number 8 copper wire is generally sufficient for grounding. However, the example specifies a number 6 ground, which provides an extra margin of safety. The conduit size, in this case 1¼ inch, needs to be large enough to accommodate all the conductors and grounding wire. NEC Chapter 9 provides guidelines for conduit fill, specifying the maximum number of conductors allowed in a conduit of a given size. It is essential to ensure that the conduit is not overfilled, as this can lead to overheating and potential damage to the conductors. A main circuit box, typically a panel board, contains a main circuit breaker that serves as the main disconnect for the entire circuit. This main breaker protects the entire downstream circuitry from overloads and short circuits. The panel board also contains branch circuit breakers, which protect individual circuits within the building. When installing a main circuit box, it is crucial to follow all applicable electrical codes and safety regulations. The panel board must be properly grounded to prevent electrical shocks. All connections must be tight and secure to prevent loose connections, which can lead to arcing and overheating. Furthermore, the panel board must be adequately sized to accommodate all the necessary circuit breakers. It is also important to consider future expansion when selecting a panel board. Choose a panel board with enough spare spaces to accommodate additional circuits that may be needed in the future. When connecting the number 2 copper wire to the main circuit breaker, it is crucial to use the correct size and type of connectors. The connectors must be compatible with both the conductor material, copper, and the terminal material of the circuit breaker. Use an antioxidant joint compound for aluminum to copper connections. This will prevent oxidation from forming due to dissimilar metals. Ensure that the connectors are properly tightened to the manufacturer's specifications. Over-tightening can damage the connector, while under-tightening can lead to loose connections and overheating. The number 6 ground wire should be connected to the grounding busbar in the panel board. The grounding busbar is a dedicated terminal for connecting all the grounding conductors in the electrical system. The grounding busbar must be properly connected to the building's grounding electrode system, which typically consists of a ground rod, water pipe, or concrete-encased electrode. The grounding electrode system provides a low impedance path for fault currents to return to the source, helping to protect people and equipment from electrical shock. The NEC requires that all electrical equipment be properly labeled. The panel board should be labeled with a voltage, current rating, and the date of installation. Each circuit breaker should be labeled with the corresponding circuit it serves. This labeling helps to ensure that the electrical system is properly maintained and operated safely. Regular inspections of the electrical system are essential to identify and correct any potential problems. The panel board should be inspected periodically to ensure that all the circuit breakers are functioning properly and that there are no loose connections or signs of overheating. Any damaged or worn components should be replaced immediately. When working with electricity, it is crucial to take all necessary safety precautions. Always turn off the power to the circuit before working on any electrical equipment. Use properly insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. In summary, a main circuit box provides several advantages over a main lug, including improved safety, convenience, and flexibility. When installing a main circuit box, it is essential to follow all applicable electrical codes and safety regulations. Proper conductor sizing, grounding, and labeling are crucial for ensuring the safe and reliable operation of the electrical system. Remember to always prioritize safety when working with electricity. In the specific scenario described, installing a 100 amp main circuit box in the garage using number 2 copper wire and the number 6 ground wire within 1¼ inch conduit is a standard and acceptable practice, provided all connections are made properly and in accordance with the NEC. Always consult local electrical codes and regulations, as they may have specific requirements that differ from the NEC. Remember that electrical work can be dangerous, and if you're not comfortable or experienced, it's always best to consult a qualified electrician. In addition to the points already mentioned, it's worth noting some additional considerations. Surge protection. A main circuit box can easily accommodate surge protective devices, or SPDs. SPD protects sensitive electronic equipment from voltage spikes caused by lightning strikes or other electrical disturbances. Installing an SPD in the main circuit box can help to prevent damage to valuable appliances and electronics throughout the building. Arc fault circuit interrupters, or ASIs. ASIs are special types of circuit breakers that are designed to detect arc faults, which are a common cause of electrical fires. ASIs are required in many areas of the home, such as bedrooms, to provide enhanced protection against electrical fires. A main circuit box allows for the easy installation of ASIs on the appropriate circuits. Ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electrical shock. GFCIs are required in areas where there is a risk of exposure to water, such as bathrooms, kitchens, and outdoor areas. A main circuit box allows for the easy installation of GFCIs on the appropriate circuits. Load calculations. Before installing a main circuit box, it is essential to perform a load calculation to determine the total electrical load that the system will need to support. The load calculation should take into account all the appliances, lighting, and other electrical equipment that will be connected to the system. The size of the main circuit breaker and the conductors must be adequate to handle the calculated load. Coordination. Coordination refers to the selective tripping of circuit breakers in the event of a fault. Ideally, only the circuit breaker closest to the fault should trip, leaving the rest of the system operational. A properly designed and installed electrical system will have coordinated circuit breakers to minimize disruptions in service. Future expansion. When selecting a main circuit box, it is important to consider the possibility of future expansion. Choose a panel board with enough spare spaces to accommodate additional circuits that may be needed in the future. It is also important to ensure that the service entrance conductors are large enough to handle any potential increase in load. Documentation. It is essential to keep accurate records of all electrical work performed. This includes the load calculation, wiring diagrams, and any other relevant information. This documentation can be helpful for future maintenance and troubleshooting. Energy efficiency. Consider the energy efficiency of the electrical system when selecting components and designing the layout. Use energy-efficient lighting and appliances to reduce energy consumption. Install occupancy sensors to automatically turn off lights in unoccupied areas. Power quality. Power quality refers to the stability and reliability of the electrical power supply. Poor power quality can damage sensitive electronic equipment. A main circuit box can be equipped with power quality monitoring devices to detect and correct any power quality problems. Safety standards. Ensure that all electrical work is performed in accordance with the latest safety standards. The NEC is the primary safety standard for electrical installations in the United States. Consult local electrical codes and regulations for any additional requirements. Professional installation. Electrical work can be dangerous, and it is always best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge, skills, and experience to ensure that the electrical system is installed safely and correctly. Maintenance. Regular maintenance is essential to ensure the safe and reliable operation of the electrical system. Inspect the panel board periodically for any signs of damage or wear. Test the circuit breakers to ensure that they are functioning properly. Replace any damaged or worn components immediately. By carefully considering all these factors, you can ensure that your electrical system is safe, reliable, and efficient. Always remember to prioritize safety when working with electricity. If you're not comfortable or experienced, it's always best to consult a qualified electrician.